Students, welcome to my lecture number 21. We had discussed in the previous lecture about the fertilizer equipment. We had talked of a GPS based fertilizer application system. We have talked of embedded system and GPS module based application system of fertilizer. Now, we will talk about the seeding equipment design. It is very important here. Now, since there are various components of a seeding equipment, for example, you would like to know that what will be the hopper size, what should be the metering mechanism, type of metering mechanism, size, material of construction of that, what will be the power transmission, and what are the other details of that, how do we do about this. So, this lecture I have divided into 3 parts, the design, because every part you must understand each part in detail, so that when you have to design the machine for any other operation or any other seed, you will be in a better position to do this job. So, I have broken down into 3 parts. In the first one, I will be talking of, in part 1 of this seeding equipment design, we will talk of the hopper. We will just talk of the hopper. Now, where is the location of the hopper? What are there with respect to the hopper? Where will be the metering shaft there? What type of metering will be there? All this design. So, if we talk of the examples of shapes of seed boxes and placing feeding rolls. Now, there could be various examples, but definitely you know that the angle of repose is one which plays a very big role in storing the material, because there should be proper flowability of the seed when we are talking of seed or when we are talking of fertilizer, because for a fertilizer, of course, it is a hygroscopic material. So, there has to be a stirrer which will be always stirring, and so that the lumps do not get formed and then have problem in the delivery of that fertilizer. But when we are talking of the seed equipment, we do not need that much of stirring of that, but what we require, there should be movement of this, there should be proper inclination given to the hopper. So, we will talk of the hopper and what are the different locations at which the metering system should be there. So, if you see this, number 1 here, the grain box is made of mild steel sheet or galvanized sheet. This is the material of construction. We have certain aspects. One is the feeding rolls. Where should we put the feeding rolls? Under the box bottom. Yes, here this is where it is. We can have on the box side walls, we can have this is the view, we can have on the side walls, you can have it, or you can have inside the box, totally inside the box, you can have this system. Here there will be system for opening and the material can follow from here. These are the 3 types. Now, the grain box is made of mild steel sheet or galvanized steel. Well, this is the material of construction and it depends on what you want to do. It will vary from the sophistication level you want, or if you want a lighter one, then accordingly you have to go to plastics and various other aspects of the design of the material or selection of the material of the hopper. The cross section, as I said, cross section will have a greater bearing on the angle of repose of that. So, most of the hoppers do have these 2 types, the trapezoidal shape or triangular shaped ones. The angle of inclination from the front and rear walls is greater than the maximum angle of repose of the material used. Yes, this we need to have, because so that there is proper flowability of the material, that is more important, and that is why we have a greater angle in this case. Now, let us see what we have planned further when we are talking of the design of the hopper. Well, first of all, you must know you are designing for what type of power source. Now, we will limit our discussion to the power source, particularly with respect to tractor, because when we are talking of machinery, we are talking of power sources and medium to large power sources. So, when I talk of medium, we talk of say lower horsepower tractors to high horsepower tractors. Now, for that, first thing which we will be required is how long will be the width of this particular drill or the seed drill which will be there, and accordingly what will be the size of the seed hopper. So, you can see that the working width of this is given by very simple. I mean, it is very simple to understand the number of rows and the distance between the consecutive. So, this is the total working width which will be there. Now, this working width, when we are talking of, this is the total working width of the system. Now, when we are talking of the design of the seed hopper here, we would like to get the total length of that. Now, definitely you will appreciate the point that it should not be very wide beyond the width of the tractor, because then it will have other complications, particularly while moving you will require a lot of headland management, and while transportation also of this. So, we generally limit, that becomes the width of that. So, an idea is there that what should be the length there. So, accordingly we have put here the length of the box given like this, when we have the working width minus 2b. This small distances we have kept, because this is the box wall, side box wall and ground wheel. This is the distance we want to maintain certain. Now, you would say how much and all that. Well, it is all something from the rule of thumb, something from experience which comes. So, we will talk of these values later, but then you have to have in between this. So, you get an idea about what is the total length of this. Now, here the details are shown. Let us proceed. Find out the size and capacity of the hopper. Well, when to actual area covered by the seed drill. Now, once we know, we need to have some basic information that what should be the size. Length is known, that what will be the other sizes of that, dimensions of that. But then this will depend on actual field capacity of the drill, how much field capacity we are planning to have. So, this will depend on the speed, the working width of the drill and the field efficiency. Now, when we talk of the design of the hopper for such a capacity, what sort of refilling, because you do not want that once the tractor goes into the field, and if the field is very large, about 10 hectares, 15 hectares, 20 hectares, 100 hectares, you would not like that once they start it should just finish and then come back, definitely not. So, considering all the practical points of view, you would like that we should have some refilling of this, and the moment you talk of refilling, you would also talk of how much should be the filling onto that box in the seed drill. So, this will further, what is the seed rate you want, how much area you want to cover for unit of time or in a given time. So, if you assume that we want to cover certain say we will take recess, or while we will stop the work after some time and then fill up, then that gives you an idea about the amount of the seed which you want to have inside this. So, the volume of the seed hopper. Now, then it is easier now, it is very simple. If you go through the details of this diagram which I have given here, you will be able to understand how to get the volume of the seed hopper. Volume of the seed hopper here, and then the trapezoidal section, we are giving the trapezoidal section here. So, from standard knowledge of geometry, you should be in a position to get this Vs with respect to what is the bottom width of the hopper, what is the top width of the hopper, what is the length of the seed hopper, and what is the height of the seed hopper. So, knowing all this, you will be in a position to get these seed hoppers dimensions. Some idea is given over here that if the seeds are say wheat seed, then the bulk density is there, because you will require the total weight, because that weight is to be carried by the seed hopper. So, you will definitely require what should be the strength of the material of the construction of the body of the hopper, and hence the thickness, because it should be able to take that much of load. So, for some we have given you this bulk density for paddy, maize, soybean, gram, groundnut. These are the values which have been given. You can utilize these values when you want to design. Well, continuation from there, here we have made it very simple. You can go through, if you go through these slowly, you will understand each step. You will be in a position to find out how we are in a how we have found out the Vs with respect to the different dimensions of the hopper. The details of nomenclature of all these have been given, and it should help you in finding out the total volume of the unit. Certain other information which we have given is the capacity. What are the general capacity of these hopper, capacity of these hoppers? So, for example, say manually drawn seed drill. If you have manually drawn seed drill, this is the amount varying between this to this. Animal drawn seed drill about this meter cube is the capacity. Tractor drawn units about 1.5 to 2 meter will have so much meter 0.15 meter cube capacity, or tractor drawn units 3 meter or above, something of this. Now, this is from design data book which we have got from this particular source. So, we have given it for your information at this point of time, depending on what you want to do. So, it is very nicely explained here, and you would be in a position to understand this with little bit of geometry knowledge which you have already, I am sure. The thickness of the seed hopper. Well, considering all your machine design knowledge on the total weight which is coming onto the hopper material and the shape, etc., I am sure you would be in a position to find out what is the thickness, and you will go to the market for selection of that material's thickness, and many times if you see that the you find out the thickness is about 2 mm, and the sheet which is available either for 1.8 mm or mm, or is available for 2.5 mm or 3 mm. Now, depending upon your requirement, if something in between here, in between here, in between here, now it is your experience or your designer's point of view that you will choose a material which is slightly stronger, and because it will have to work for a longer duration of time, we would like to take even slight higher thickness will help us. So, from the literature and from our experience, we have found out that for if you take mild steel sheet, then this is the thickness which you can pick up from the market. If you take a galvanized sheet, this is the thickness which will do the job. So, this will help you in getting this information, and hence you can find out the thickness of this. Now, a problem has been given to you so that you are in a position to understand what is this and how do we actually use the information or knowledge which has been given to you. It is like this. Find out the capacity and dimensions of a seed hopper for sowing wheat having bulk density of 700 kg per meter cube and seed rate is 100 kg per hectare. The drill needs to be refilled after every hour. This is the requirement. The length of the seed hopper is 1.8 meter. A limitation has been given to you, and maybe this is a data which will help you to proceed at from some point of time if you go back to the informations or the equations which we have given earlier. So, this will help you in putting this value and coming out with the details. And tractor is moving at a forward speed of 4 km per hour. If the speed is 4 km per hour, so you will have some information as to when it is moving at certain kilometer, how much width it is covering. You will definitely need to guess certain things so that you can find out the capacity and dimensions of the seed hopper. Now, we have done it for you here. Now, actual field capacity of a drill, where here we mean here a seed drill, seed drill here. So, at this location also we do mean seed drill. So, you see that actual field capacity from standard information that we will find the width, the speed of operation by 10 and to the efficiency. So, this will give you straight away what is the actual field capacity of a particular seed drill. If the width is about if the length is 1.8 and the speed of operation is this. So, width into length by 10, the units have been taken care of, and so accordingly you will get. So, you find here that the actual is 0.54 hectare per hour, this is the capacity. So, if you see this, so weight of seed to be used in 1 hour will be seed rate, which is known to you, and then area covered per hour into the time. So, we have taken time of about 1 hour. So, every 1 hour we need to refill. So, we should be knowing what is the amount that has to be there. So, very simple, if you multiply you get that this is the amount of seed that should be there in the hopper. So, if you have this information, then you work back about the dimensions of this. It talks of the capacity and dimensions of seed hopper. So, this information has given you straight away how much is the total weight which you want to have inside. Then let us go into details further. Well, then volume, because you can find that a data is also given about the density of the seed. The seed here is wheat seed, which has been given in the problem. So, once we know the weight of the seed and using the density of seed, you should be in a position to find out what is the volume of the seed box. So, this is the volume of the seed box. Now, we do not, as I was talking earlier at some point, that we do not fill just up to the brim of that, which we call as the truck capacity. I can explain that if you have something like this and if you fill up like this, this is called the truck capacity. This is called truck capacity, but we do not fill it like this. We do have certain freeboard, and we do not want, because when the machine is going inside, we would not like to fill up this, but there will be a certain freeboard. So, this we will not fill up, right? This we will not fill up, but then it will not be like this. It will be virtually, you will find that this will become something like, if it is up to this, then it will be something like this here. Yes, that means it will not be because of the shape, it will cover something like this. So, it will not be a truck capacity, but a heaped capacity, as if there is a heap which is kept inside that regular shape. So, therefore, we will take up a freeboard, which you might have also come across such a thing when you are deciding about irrigation problems and all that, you might have come across. So, this could be taken as 10% here. Now, using this as 10%, we get that the volume, actual volume then gets modified to this. We would like to have this. So, let this seed box, let the seed box be of trapezoidal section, which we have already taken that. Okay, we will go for this either triangular or trapezoidal. So, we will take because we have discussed this, we will take a trapezoidal section. Now, we can divide total seed box into two sections. The volume seed box is given, therefore, the volume of the seed box is given as this. Now, this will come depending upon how you understand the details of the seed box theory, which we have given to you, and on that basis you will be in a position to find out the total volume of the seed box Vs. Assuming base width, well, this is important actually. As I said, as a designer, you need to have some experience of what it is, or if you are a new designer, you must see what are the already available equipment and what are their relevant values. You can measure them and find out and have some idea why they are, depending upon the information that you want to gather. So, it is very essential for a designer to have this information in hand, and on that basis only, let us assume A. Now, this data A has been taken as 10 centimeter. Why we assume? As I said, that we need to assume if you go through the already available machines or the fertilizer or seed drill machines, you will find that the values vary around 10-12 centimeters or so. So, we have taken that, okay, let us say this is this. Now, angle of inclination of the hopper. Now, this is important. We said while designing that we take a value higher than that of the angle of repose of that, and the values varies from about 68 to 72 degrees or so. So, therefore, in this we have taken about 70 degrees. So, if you take this as 70 degrees, we are in a position to get the h value, which is this here, that the total height of this will be given as 24.8 centimeter. If you put those details, you will be in a position to get this. I need not go into calculation and showing to you. You are smart enough to understand how we can get this. So, Vs is then using the Vs equation which was given earlier, we are in a position to get B, and this B is this portion here, the total. Now, the top of this, once we have A has been found out, B has been taken and the value of H has been found. So, we know virtually every dimension of that, and once you know this dimension, you know the length of it, you should be in a position to find out the capacity and the dimensions of all the details. So, using this dimensions of the hopper that have been designed here for the problem in question, the A is this value, then top width 57.7, then height of the hopper, and volume of this is this. So, this is an example which explains what we had taught you there and what is over here. If you want to take up more this thing, you can design your own problems, or if you have any questions about that, you can always ask us about those questions we would like to answer, and maybe that in due course of time when we have the assignments and other discussions, we will talk more about these things and clarify if any doubts wherever whatsoever. Thank you. ठीक ही है अभी, within time था.